This video, presented to you by the Noardia Group, will briefly describe the history and technology of solar power and fuel cells. People have been trying to harness solar power for centuries, with mirrors used as means to start cooking fires as far back as 700 BC. The photovoltaic effect was discovered in 1839 by Edmund Becquerel, with the first solar cell being designed some decades later by Charles Fritts in 1883. 1958, the first solar-powered satellite, Vanguard 1, was launched. Solar water heating was the first commercial success, and by the early 2000s, thin film and printable technology was developed. Now, solar is regularly used for residential and industrial power generation, with the current focus being on the development of microgrids and power storage. Solar photovoltaic technology directly converts sunlight into electricity at an atomic level. The technology uses semiconducting materials, like silicon, to absorb photons of light, which agitate and release electrons from their usual molecular orbit. These electrons are then captured in the metal frames of the cells, creating a DC current. The technology is still very inefficient, only converting about 26% of the available power. But new materials and technology are emerging, which are covered more extensively in the accompanying report. Concentrated solar power systems are characterized by focusing solar radiation onto a receiver, where it is then absorbed and converted into heat. A heat transfer fluid then carries the heat from the receiver to a steam or gas turbine that is connected to an electrical power generator. Unlike solar power, which is relatively simple in concept, fuel cells are a bit more complicated. A fuel cell converts energy created by a chemical reaction into electrical power. It usually uses some form of oxygen and hydrogen as its fuel, which creates relatively clean water. This makes it an interesting and eco-friendly power source. In 1801, chemist Humphrey Davy first conceptualized the fuel cell. By 1839, Sir William Grove had developed a prototype, but the first practical design didn't actually come until 1959, when Francis Bacon created a 5 kilowatt hydrogen-air fuel cell. From there, the technology developed quickly. By the late 1960s, General Electric was able to use fuel cells to power the capsules in the Gemini and Apollo space programs. Today, fuel cells have been commercialized for both consumers and industry. One of the most commonly used fuel cells is the proton exchange membrane cell. It's a stable and portable power source. It also has a high energy to rate ratio. With both a compact size and quick startup, PEM cells have been developed for use in vehicles since the early 1990s. The alkaline fuel cell is one of the oldest fuel cell designs. It operates via the conversion of hydrogen and oxygen to water. The NASA space program has used them since the 1960s. The AFC has a relatively simple design, but it's also large and it requires a very pure source of hydrogen and oxygen, because its efficiency sharply declines when impurities are introduced. The molten carbonate fuel cell uses high-temperature compounds of salt, such as sodium or magnesium, to create a net transfer of carbon dioxide across the cell. It has a high operating temperature of about 650 degrees. This does limit its uses, but it has a high efficiency, and unlike alkaline cells, it can utilize various fuels including natural gas, biogas and syngas. This is because the high temperatures can degrade most of the impurities in the fuel. The microbial fuel cell has emerged as a versatile technology. It's usable as a power source and for wastewater treatment. It uses bacteria to convert wastewater into carbon dioxide and hydrogen, which is then converted into power and water. Although it's more widely studied for power generation, it has also been studied as a way to remove heavy metals and other toxic elements from wastewater. So that was a brief overview of the history and technology of solar power and fuel cells. We can only wait to see how the two technologies develop from here. They both have a promising future ahead. For more details on solar technology and fuel cell technology, please read our report.